Welcome back, guys. So we're now going to add another piece to this quadratic function. We've established that A is going to affect the dilation, whether it's going to be skinnier or, wider. Yep. And obviously, it's also going to dictate whether it's going to be upright or whether it's going to be inverted. Now, what we're going to do is we're going to add a constant, plus c, to this equation. So instead of y equals ax squared, it's going to be y equals ax squared plus c. And we'll see what this addition to the equation is going to do to our quadratic function. Okay, so let's get straight into it here. Here we have our y equals x squared, and we know that if we make things, make x squared negative, it makes it inverted upside down. Okay, but what happens if we add 2? So y equals x squared plus 2, we could see that the shape looks very much the same, but it's shifted or translated vertically, and in this case it's moved up 2 units. And we would then think that, well, if adding 2 is going to move it up, then perhaps when we subtract 2, it's going to move it down, which is what has happened. It hasn't affected the dilation. It's still the same in terms of the width of the parabola. It's just shifted up and down based on the constant. We can also see that the y-intercept is also the same value as this translation. Okay, so we can talk about this y-intercept when x equals 0. It fits what we've learnt in the past with linear graphs as well, that your y-intercept is when x equals 0, so you would do the same thing with quadratics, nothing different. Now, would it change with an inverted parabola? It wouldn't make any difference. Okay, so here we have an inverted parabola. It's upside down. Again, if we're going to add 6, it would move the parabola 6 units upwards, which is what's displayed here. And then if we were to subtract 4 units, okay, so y equals minus x squared minus 4, then it's going to shift the parabola down 4 units, as so. So we can see all of this all combined if we compare them all together. So we haven't played around with dilation here. All we're looking at is where it's moving up and down that vertical axis. But if we were to just recap on dilation, and we put a 2x squared here, then obviously if we had a 4x squared plus 2, not only is the parabola going to be skinnier, but it's going to move up 2 units. And what we have here, yes, the purple is skinnier than the red, and it has shifted 2 units up. Same thing if we were to look at inverted parabolas, and let's say we went with a half x squared, then that's obviously going to be wider. If we ended up having something like, say, 3/5 x squared, and this is where your familiarity with fractions and being able to compare fractions, and we'll go with minus 2. So first thing is, I guess the question is a half greater or less than 3/5? I can say that 3/5 is more than a half, so therefore the parabola should be skinnier than a half x squared. At the same time, because it's inverted, we dictated by the negative, it's upside down, and then it's moved 2 units downwards. It's translated vertically down 2 units. So let's see what that looks like. Yep, so as we predicted, it's moved 2 units down, and it's slightly skinnier than the green. Okay, it's only slightly more than just a half. If we made this a positive, it wouldn't be wouldn't be inverted anymore. It would just be upright instead. So that's just connecting everything together now in terms of manipulating the coefficient of x squared and adding a constant to the quadratic function. I'm just going to quickly finish off with an example, a question, and then the next video we're going to build onto this structure again. Okay, so we have this question of a bowl, okay, and it's a very interesting equation for the bowl, but here's the shape of the bowl. Well, I guess what comes to mind fairly simply. And there's three points to this question. And it's asking where, what happens, what are the points of x when y equals 0? And we'll do that through factorization and the null factor law. Again, going back to quadratic equations from the previous chapter. And what is the depth of the bowl? What is the width of the bowl? And we'll go through a few of these things in this question. So first thing, let's factorize. So we got 3x squared minus 243. And we've got a factor of 3. So let's take that out. And 243 divided by 3 is 81. So what we'll have here is we have a difference of perfect squares. And knowing your shortcuts, this should be x plus 9 and x minus 9 is equal to 0. So what we'll have here is solutions for x. Solutions for x is going to be plus or minus 9. Okay, and let's just make some more space here. So here we have our y axis. Here we have our x-axis, and what we also know from our previous, just from earlier on, we have 3, meaning that it is going to be a skinny parabola, skinnier compared to x squared, and we have a y-intercept of minus 243. It's a very strange bowl, but we're going to be working through that. So minus 243 is over there, and our bowl is going to look somewhat like that. Okay. What you'll need to realize is that these values for, or solutions for x, are actually solving these points of the parabola. So that's minus 9 and that's positive 9. So to cut to the punchline of things, when you factorize a quadratic expression and you solve or you work out the solutions for x in your quadratic expression, you are essentially working out the x-intercepts for a quadratic, for a parabola. Okay, so in this case here, we've got two solutions being positive 9 and negative 9. We know that our y-intercept is at negative 243 because of the vertical translation. And we can now answer each of these questions. So the points where y equals 0, these are our x-intercepts. Okay, so that's the answer for the first question. The depth of the bowl is minus, or let's say, just 243 units. Okay. In this case, in centimeters, according to the question. And what's the width of the bowl? Well, if it's going to be 9 units from the center and then 9 units across to the other side, we're looking at 18 centimeters wide. Okay. Now, the value, one thing I'd like to highlight, this distance here between the two x-intercepts is what you'll consider as a domain. Okay, so if there's any question in regards to asking what the domain is, then you could say the domain is basically between minus 9 and 9. So this is, let me just write that properly, minus 9 and positive 9. Okay, so hopefully that answers your question or provides a little bit more clarity in regards to the vertical translation or adding the constant to our quadratic function. If you have any questions, let me know. Otherwise, see you in the next video.